Hello and welcome to another one of these ADD videos. Today we're going to be looking at the problem of empirical formula but given to us as a percentage by weight. Okay? And in this problem we have a sample that has three elements: carbon, nitrogen, and oxygen, given percentages. How would we go about solving this? For best results, pause this video, attempt this problem on your own, and then watch the solution and see if you got it right. Alright, let's get started. What's the first thing you should do? Well, we have percentages. That's a problem. We need to get from percentages into grams. So, how do we do that? Well, what we do is we assume that we have 100 grams of our sample, then all of these percentages up here become grams. We have 45 grams of carbon, 20 grams of nitrogen, and the rest, which if you just do 100 minus 65, the sum of these two, will give you what oxygen is. Alright, so we've got grams. The next step would be to convert everything into moles. Okay? The way we do that is we go to our handy dandy periodic table and we look up the molecular masses of our periodic table of these elements. So carbon is 12.01, nitrogen is 14.01, and oxygen is 15.99. Alright, so if you do that and you find the moles by dividing by the molecular mass, this is what you'll get. 3.75 moles of carbon, 1.43 moles of nitrogen, and 2.19 moles of oxygen. I do these stoichiometry tables in order to visualize my conversions much easier. I can put what I have down on the bottom so that they can cancel, and what I need on top, giving me what I want. Alright, so if I do that for all of those, I get those. But now what I have to do is I have to divide each one of those by the smallest value. Okay, and if you look, nitrogen has a 1.43 moles of nitrogen, so divide each of those by 1.43. When you do that, you get these numbers here. The carbon is 2.62. Nitrogen, of course, by itself is going to give you 1. And then when you do oxygen, you're going to have 1.53. So depending on what your source is, you will have a criteria that you have to be within plus or minus either 0.1 or 0.2 of a whole number when you divide by the smallest number of moles. As you can see, this one is not. Neither is oxygen. Carbon and oxygen are far off from being that value. So what we do is we start multiplying by 2, all of them by 3, until they all get within that plus or minus 0.2. In our school we do 0.2 range. Okay? So if you multiply by 2 in this case, we get the carbon becomes 5.2, which is close enough to 5 to assume it's a whole number. Nitrogen becomes 2, because it's 2 times 1. And 3.06 is pretty close to a whole number of 3. It's within that allowable plus or minus 0.2 range. So as a result, then you can determine the empirical formula by just adding those subscripts to those elements. The 5 for the carbon, the 2 for the nitrogen, and the 3 for the oxygen. Okay? That's basically it. This is about as hard as they get. Typically with these percent masses, I haven't seen it too much worse than this. Know that you might be asked to find the formula for the molecular formula. This empirical formula is just a basic version of this combination of elements. You can have multiples of these subscripts to get some other compounds. Okay, and you can check out the molecular formula video for an example like that. Alright, so practice, practice, practice is the key as always. Make sure that you have watched all the example videos and take good notes in class. But there's no substitute for you doing problems and practicing and reading on your own. No amount of videos or tutoring will ever replace that. Alright, thank you and have a nice day.